Welcome to this session of 50th International Symposium on Multidisciplinary Studies and Innovative Technologies. My name is Emir Köksal. I'm a professor doctor in the Department of Mathematics of 19 Mayıs University. We have 9 presentations in this session. The first 2 presentations will be given by Kostas Pepas. The title of his first talk is Information and Communication Technologies in Speech and Language Therapy Towards Enhancing Phonological Performance. The title of his second talk is Exploring the Speech Language Therapy Through Information Communication Technologies, Machine Learning, and Neural Network. Duration of each presentation is 10 minutes. Please pay attention duration of presentation because we have other session after this session. Okay, Kostas?
Hello everybody, I'm Kostas Pepas. I'm assistant professor in the University of Peloponnese Tripolis, and I'm going to present 2 papers. The first, just a moment please to share the screen. One moment, please give me 1 moment. Is the screen available to everybody? Okay.
Yes, we see your screen, you can start, yes.
This is the first presentation entitled Information and Communication Technologies in Speech and Language Therapy Towards Enhancing Phonological Performance. Just one question, please, before proceeding. The maximum allowable time is 7 minutes per each presentation. Is this correct? 7 minutes for each presentation. Okay, is it okay? Okay. For further questions, for further information related to this presentation, please send email to Mr. Kostas Drossos or Professor Tafiadis or Professor Toki. Just some brief information on the purpose of this work. Information and communication technologies have been utilized in the educational process in order to enrich and enhance the conventional traditional teaching methods. The purpose of this work was to explore the potential of utilizing ISTs as both an educational and therapeutic tool in preschool children with speech and language difficulties in the Greek language. Those results obtained from previous research have revealed improvement in phonological awareness and vocabulary for this specific group of children. And this finding is considered to be important, especially in situations and circumstances when social distances is given, just in the pandemic of COVID-19. As far as the language development is concerned, the linguistic environment of the children can significantly be affected by the development of oral language. And the oral interaction with peers, with both peers and adults, can improve the language development through the introduction and use of new words, of concepts, or language structures. What are the 4 basic skills demanded? Are syntax, semantics, phonology, and praxis. And these skills influence the creative process of both understanding and delivering speech. Regarding the phonological awareness, the term emergent literacy encompasses early speech skills that evolve and structure young children's reading and writing behaviors. These skills refer to coding and decoding the written languages, understanding the content, and the actual maturation of the child during preschool before entering the primary school, and the systematic exposure to reading and writing activities. Now, when children want to learn to read and write, they should already know the sounds of their mother tongue. How is phonological awareness achieved? It is achieved by segmental phonemes as the smallest audio elements in words and phrases. Regarding the purpose of this study, information and communication technologies, it has been revealed by significant evidences that ICTs have educational benefits, especially in preschool education, while they provide a collaborative learning environment. The purpose of this study was to validate ICTs and the relevant tools for preschool children having speech-language difficulties. We refer to the Greek language. The new technology's contribution in the design and the implementation of personalized learning and speech therapy programs has been recorded. The recording involves phonological awareness and vocabulary development, as they are important for oral and written precursor skills. What methods have we followed? We have conducted research studies in private schools from Greece. In this study, they have participated 80 children, among of which were 42 boys and 38 girls, having ages ranging from 4.6 to 5.9 years, having a median value of 5.24, who have never been examined before by formal or informal speech and language assessment. The participating children had the typical deployment according to the individual files held in their school, and at the end of their 6 months intervention program, these 80 children have been reevaluated with using the same assessment tools, and their performance have been recorded accordingly. Then we have conducted a statistical analysis and comparisons of both the initial and final performance of children of each school based on IBM SPSS. And in general, the sample data have been found to follow a normal distribution. Now, about the tools we have used for phonological awareness evaluation, it was selected the short version of the metaphone test by Giannatopoulou and Kirpotin, and for the evaluation of the expressive vocabulary, the so-called expressive have been selected. Now, as far as the speech structure and the storytelling ability is concerned, we have used the action pictures, information, and the grammar proficiency test. The controlled group have participated in group game and storytelling in the context of school curriculum, and the therapy program included new technologies, which included electronic learning materials and specialized apps available on iPad tablets. Now, again, regarding the methodology, the sample consists of the control group, and the 20 children were the control group and 60 the experimental group, following the Sarmas sampling model. And for the study, the 60 children were divided into 3 smaller groups, each one of which consisted of 20 individuals according to the type of the intervention. Next, this group has been randomly divided by lot during the treatment program, and this lasted 6 months with a frequency of 2 times per week for 45-minute sessions. A for individual session without using new technologies, this session, and B for the session using new technologies, whereas the C section was used for group therapy employing new technologies. About the results, one-way ANOVA analysis has been conducted for discovering potential significant differences or not between 2 samples means, and then we conducted a per-sample student test in order to discover, if possible, whether the mean difference relevant to group of the observations are equal to 0. Finally, we conducted independent sample t-test in order to compare the means of the 2 independent groups and exploring whether or not the populations of the group appear to be significantly different to each other. Now, about the results, the one-way ANOVA has been used to determine use difference derived from the conducted evaluations in the study, and the conducted analysis has shown to be statistically significant differences for the initial phonological evaluation scores using an F of 3.76 equal to 49.0.58 and a confidence level of less than 1x minus 3, whereas for the final phonological evaluation, the score was 51.106 with a p-value of less than 1x minus 3 between all groups. Again, the statistical analysis conducted have revealed a total score of 19.4 with p-value again less than 1x minus 3. And the final evaluation of the vocabulary total score was observed to be 6.192 with a p-value equal to 1x minus 3 between all groups. These results are also summarized in Table 1, which is also available in the printed versions of our papers. The means comparisons between the initial and the final evaluation of the phonological group and the vocabulary level showed statistically significant difference, as also shown from this table. For example, the comparisons of the means between the initial and the final evaluation of phonological awareness has revealed statistically significant differences between these evaluations. Again, an independent sample test has been conducted, as also mentioned before, and a statistically significant difference has been observed with the total scores between the CG and the STG groups. This information is also available in the full text, and statistically significant differences has been observed between the CG and the STNTG groups, the CG and the GTNT groups. Now, moving to the pairwise comparisons of means between the CG group and the other groups on the final testing of phonological awareness total scores, our analysis has revealed again statistical difference between these groups, and similar results, similar findings have been reported between the STG groups and the STNG groups on the final testing. Some discussion on the results that there has not been an extensive study comparing the use of software and traditional activities in children with language disorders, whereas on the contrary, these studies focused, we have contracted our efforts, our research efforts towards accomplishing at least a significant purpose, which has to show the real benefits from the use of software into various groups. Some other thoughts and interpretations of this group is that the data analysis of this study emphasized that the most appropriate method of therapeutic approach in the preschool children with speech or speech deficits is the group cooperative approach. Moreover, our results have shown that the team that has implemented teamwork activities outperformed possibly at the time of test in all specific areas of interest. Now, again, the above group session with the use of new technologies augments the learning outcomes via the cooperation of the group members, and we have found that the new technologies as a source of stimulation impress children, please them, increase their curiosity, their tendency to discover. Some other thoughts is that all children having speech language difficulties have shown significant progressions as compared to the children in the control group. And it has also been evident that the learning outcome associated with reading skills is similar for all children who had independent group therapy program. Next, the children group who employed our new technologies, as well as software running on an iPad, whereas at the same time work together, have recorded a higher performance, thus indicating that when the specialists use new technology programs in their treatment protocols to preschool children, learning in the areas of phonology, storytelling, and vocabulary can be enhanced significantly. Again, this study emerges that new technology can be used as an alternative tool method that supports both the classical approach to treatment as reported in the open literature. Some limitations on the studies is that there is not a significant single evaluation tool or toolkit that has been developed by the same body and that covers the full range of development features, either in paper or in electronic form. Next, the assessment tools, the online assessment tools in Greek language are available for school-age children or in the grading process. The professional and parents' opinions on the use of new technologies and capabilities are not recorded, and this has been left as a future contributions. And then most of the needed software, for example, for tablets, is not available in Greek. In the future, we plan to use additional digital material and also to extend this work to a larger population of preschool or early school children. Summarizing this presentation, the purpose of this research study has been accomplished through the use of ICTs and it suggested that the use of new technologies in small groups of kindergarten children is appropriate for the formulation and implementation of therapeutic protocols. Thank you for watching. If there are any questions.
Is there any question, comments, or remark? No question. Thank you very much for your first presentation.
Thank you very much, Professor. We continue now to the second.
Sure, you can start your second presentation.
Okay. The second presentation has the title Exploring the Speech Language Therapy through Information Communication Technologies, Machine Learning, and Neural Networks. What is the aim of the study? First of all, the aim of the study is fourfold. First of all, is to discover a model to predict potential benefits from the online form of speech and language therapy that involves specialists, parents, and children. Second is to give a methodology for recording the views of the involved speech therapists and parents. Third, to validate the primary version of the research with a random sample. And finally, to establish the methodology of applied statistical analysis and construction of neural networks for this specific scientific area of research. Well, in the introduction of this presentation, we bring some information about SLT. In the current day, there is a vast number of communication disorders in both children and adults, and these disorders needs special attentions as well as appropriate caring using speech-language therapy. Speech-language therapy is a scientific area of expertise for diagnosing and treating the aforementioned disorder. More specifically, as far as the children case is concerned, SLT is related to the handling of developmental problems and impending speech disorders. As far as the adult's case is concerned, this is correlated to speech disorders, which can be caused by medical conditions, for example, after an injury or a serious illness. What is now the impact of these disorders? It has been shown that these disorders exhibit a prevalence of about 10 to 15% in preschool children, 6% in students, and about 4 to 8% in individuals of 18 years old. Moreover, about 7.7% of children exhibit a disorder on voice, on speech, on language, or swallowing. 5% suffer from primary speech problems. 3.3% show a disorder in language lasting for at least a week. 1.4% has a voice disorder that again lasted at least a week, and 0.9% are discovered with difficulties in swallowing. Moreover, for the population exhibiting speech and language disorders or swallowing problems, 34% of the children having ages ranging from 3 to 10 years old, and 25.4% of children ranging from 11 to 17 years old suffered from one of the aforementioned disorders. But based on this fact, it's obvious that the area of SLT is of great importance, and it should be expanded using modern technologies. It is known that the SLTs has been diagnosing and intervening in the treatment of SLTs through edge processes, which can be accomplished either using a classical method, a live session, for example, a professional private practice, or at patient home, or even at school. Due to the pandemic conditions because of the COVID-19 pandemic, and due to the consequent advances in communications, individuals can enjoy the benefits of SLTs from a distance, for example, using online sessions. Another issue is the distant therapy, which has been gradually involved by using advanced equipment and provide a seamless experience using screens, cameras, headsets, and microphones. Now, what about using artificial intelligence methods in SLT and data science? Data mining can be positioned around the SLT essence. Data science includes more data versus data mining, as it corresponds to the full potential of a human being in regards to the SLT science. Deep learning can be more expanded, okay, as it will contribute towards finding hidden aspects of human factors which would be crucial for applying potential future therapies in the SLT fields of interest. Machine learning is the matrix of deep knowledge and act, unifying all these aspects for producing an advanced management of potential therapies through deep learning procedures. Finally, artificial intelligence is the evolution of therapeutic art, being the brain machine or the machine learning in order to combine various produced entities of the AIs. It is evident that in this level, the level of achievement, AI can be a valuable colleague to see behind the obvious and to work with the specialist for providing revolutionary constructed therapies, specifically for a considered patient. Now, with some discussion of the machine learning pipeline, based on this previous recommendation, we worked based on the steps on the machine learning pipelines, using the steps summarizing on this table, which is also available in our presentations, our printed version of our papers. These steps have been used with alteration in order to find, with our research, relevant to ICTs and perception of the participants. Now, it is believed that the evolution of this idea will lead to a more complicated results, which would be a complicated scheme of diagnosis incorporating many elements of the AI field, of the artificial intelligence field. On this project have been conducted at the University of Ioannina, Greece, starting from the middle of 2020 to the middle of 2021. This project has been conducted under realistic conditions at separate rooms of enhanced multimedia communications, one used for the specialist, whereas the other used for the child, for the parent-child pair. All participants have signed a written consensus that confirms their will to participate, to contribute to this research, and the hypothetical sample, which has been randomly generated by software, has been consisted of 50 specialists having language, their language therapists of various academic levels. For example, those without having an academic title, those having BSS, master, or PhD doctorate holders, as well as 50 parents, which are the session participants. The hypothetical role of the session specialist has been to conduct sessions with children with or without disorders. And the involved technique has a short session pilot to determine the goals, the second to inform the children parents about the procedure, the third to establish a primary schedule of proper therapy, and the fourth, the final one, is to encourage parents to address the office therapy that was suggested by the specialist. Some methods, again, step. First, the MOS methodology applied. The second step is that after a considerable number of sessions, the specialist filled the details in question, the gender, the level of education, the satisfaction from STT, the fear of being recorded, empathy if existent or no. All data has been inserted to an already known plan for us, such as an IBM SPSS, machine learning implemented, and then in this study has been conducted using a random data set for presenting this method. Some descriptive studies that the produced set of random answers has been repeated one time for specialists and one time for parents, and the sample consists of 100 randomly generated sets of answers. The sample was processed. The gender consisted of 29 males, 21 females, whereas for the parents is 50-50, is equally balanced, 25 males, 25 females. In the same table available in the paper, it is obvious that the work experience was similar for the two parties. On the contrary, as far as the IQ score is concerned, it has not been found to be equal for the two groups, but exhibited a large span between them, equal to 30. The satisfaction from the STT was similar for both groups, while the rest reported case exhibited some difference as shown in table 1. Some results on the test. Before continuing, we checked the issues that could lead to different statistical methods based on the presence or not of the normality. No further statistical methods are shown in this study, since it is not fruitful for the case of our experiment with a random sample. whereas the basic of the proposed method is shown for helping other research studies. Specifically, when examining less than 50 samples, we used the Sapir-Whorf results instead of the well-known conventional Kolmogorov-Smirnov results. Now, some information about our neural network. A random sampling was not expected to show significant correlations for items including gender, IQ, etc. And the random process is not expected to produce strong relationships, but on the contrary, some minors. This hypothesis has been proved and consequently can be used as a study validator. Regarding our implementation of the neural network, we have used a multi-layer perceptron approach, which refers to a feed-forward artificial neural networks and composed of multiple layers of perceptrons. These perceptrons, in the case of exhibit a single hidden layer, as known as vanilla neural networks. The hidden layer is a secret ingredient which can model complex data due to the neurons, the node. The values of the nodes are not known to the training dataset, so there is only input-output knowledge. And in general, this method, the multi-layer perceptron technique, includes three kinds of nodes. One node, the kind is the input, second, the hidden layer, and the output. And all nodes are considered as neurons, not the input. This is the actual implementation of the proposed neural network. We configured the MLP with a dependent variable and parents STD satisfaction. As far as the partition, 50% of the active data sets was used for training, and the remaining 30% for testing, and the architectures include the automatic range of hidden layers from 50. The analysis also included the impact of each variable in the prediction of the dependent variable. There was only one hidden layer with 10 nodes attached to it, noted hereafter as H1, 1, colon 1, H1, colon 2, etc. until 10. Some results given by the interpreting of the neural network. This model has given us significant information about the training procedure with incorrect predictions of about 18%, whereas in testing procedure, the incorrect predictions reached about 71%. And this scores imply very bad performance, which is natural as the sample is randomly generated. Now, if we neglect this fact, we continue the analysis in order to rerun the model and achieve better results. Under real conditions with a properly acquired sample, these incorrect predictions should have very low values. In order to distinguish the best independent variables or variables with higher influence, we have produced the independent variance importance table depicted in table 1. Now, the importance and the normalized version means that if the values are increased enough, as much as possibly close to 1 or 100% respectively, the independent variable has more influence. Specifically, for the next model rerun, we kept only those that exhibit a normalized score over 70%. After rerunning the model, a new independent variable importance was produced exhibiting, and this percentage denotes that the associated independence variable can predict well the independent variable. Anyway, the testing process, which are now better, are due to the better judgment of the finding for potential correct predictors. Now, some limitation and conclusion to finish this presentation. This study exhibits some limitations such as, first is the absence of a real sum. Second is the lack of weight factors for various categories for producing some correlation, even if the sample was randomly created. And the reason for not applying this adjustment was that we wanted to show the method without tiring the potential reader. The use of the sample with customized correlation, but then the results can be biased as no random processes would have been applied. We have finally some conclusions. We implemented a methodology for estimating the true benefits of RSTT. The purpose was that the predictors and influence parameters cannot be the same each time for different populations of special net parents, and we employed the method. A method is needed in order to actively estimate the factors that affect each time the success of STT without the need of using normative data that could take time to be acquired. The results were satisfactory by confirming the validity of the used sampling. Thank you very much for your attention. Any questions?
Is there any question, comment, or remark? No question. Thank you very much for your
Thank you very much,
presentation.
Professor. Thank you very much for your time.
Next speaker is Lee Tide. The title of the talk is Adaptive Thresholding with Iterative Fuzzy Logic-Based Image Enhancements for Viper Arm Defect Detection.
Can you hear me?
Yes.
Okay, good.
You can share your screen.
Yes, I'm going to.
Okay, you can
Do you
start.
see my screen now? Okay,
Sure.
all right. Okay, a very good afternoon to Mr. Chairman or present. My name is Lee Tute. I'm currently attached to the Faculty of Engineering and Technology in Tunku Abdul Rahman University College, based in Kuala Lumpur, Malaysia. I'm here today to present my student's project. His name is Chi Wei Fu. His project title is the Adaptive Thresholding with Iterative Fuzzy Logic-Based Image Enhancement for Car Wiper Arm Defect Detection. I'm going to start my presentation with a brief introduction on the background of the project, followed by a short definition of his research objectives. I will then explain the system that he proposed, followed by discussing the experimental results as well as some of his findings. I will then conclude this presentation with some highlight on the achievement that he has done and suggestion for some further work to be done. Okay, let's start with a little bit of information on the background of this project. A group of students developed a prototype of the first wiper arm defect detection system last year. 2 sets of cameras and lighting were used to acquire image of the entire wiper arm assembly, in which one set is for arm head and the other set is for retainer and arm piece. 3 sets of sequential images were acquired as the wiper arm was conveyed through the image acquisition zone in 3 orientations. That is at 0 degree, positive 45 degree, and negative 45 degree orientation, in order to cover the top primary surface and the 2 side surfaces and corners. A simple software was developed using Gaussian filters and block detectors. The overall accuracy is 88%. It was found that there is a high misdetection rate at 52%, mainly due to faint defects and defects that appear near the boundary of the region of interest. Okay, his mission was to improve the overall accuracy by reducing the misdetection rate from 52% to less than 20% and not causing high false alarms. So he approached this project with the objective of improving the image pre-processing stage by employing better image segmentation technique, better image enhancement technique, and better image thresholding technique, with the intention of improving the feature expressions of faint defects. So in order to improve the detection of near boundary defects, he worked on improving the block detection algorithm. The data set collected in the previous work was used in this project. Based on a series of extensive literature review and evaluation, the following system was proposed. So the defect detection system consists of 5 major blocks. They are segmentation, enhancement, binarization, feature preservation, and defect detection. The system was developed and tested based on a total of 384 images taken from 6 wiper arm models, in which 137 of them contain various types of defects. The program was written using Python and OpenCV2 and operated on a laptop with the specifications listed here. Now, let me explain the process in more detail. In image segmentation, the image is first converted into grayscale. Then the contour of the region of interest is acquired using improved auto thresholding technique. Medium blurring is then applied to remove any salt and pepper noise present. In the image enhancement stage, the ROI acquired is first gamma corrected to minimize uneven lighting effect, and then sharpened slightly using unsharp masking. The resultant image is then set into the iterative version of fuzzy clip contrast limited adaptive histogram equalization enhancement for final enhancement operations. In the image binarization stage, the enhanced IORI is first binarized using adaptive thresholding. A series of morphological operations are then performed to remove the salt and pepper noise. The resultant image then goes through 3 stages of filtering in order to clean up the remaining noise. Due to the complex structure, the feature of the wiper arm may be falsely detected as defects. In this example here, the first image on the left is the gamma corrected image with the rivet present along with the defect here. So in order to prevent this rivet from being extracted as a defect, the binarized image is first inverted and then converse how algorithm is applied to fill the feature with white pixel with the actual defect remain here. In the second set of image, with the structural lining here, the probabilistic hue transform is applied after binarization process. Its purpose is to fill out this series of black pixels as a solid black line. The noise due to texture surface are then removed using a series of morphological operations again, leaving the actual defect on the resultant image. So with all this pre-processing done, the image is now ready for defect detection. So depending on the camera used to capture the image, the size of the ROI, and the orientation of the wiper arm, block detection algorithm is used to pinpoint the defect on the wiper arm in 4 different stages. The first stage used the crop version of the ROI to extract the defect based on area. The second stage involves camera 2 images where the uncropped version of the ROI will be used and the block will be extracted as a defect based on the area as well as the shape of the block. The third stage actually includes detection of white block as defects. This is to counteract a bug in the simple block detector CP2 function, where large and elongated blocks are actually falsely identified as white blocks due to the center of mesh being outside the block itself. So in the 4th stage of defect detection, the shape of the defect is acquired. And defects that are detected in the previous stage with mean gray value higher than a certain threshold value are filtered off here as well. So this will ensure that only blocks that are dark enough are considered as defects. So in this diagram, the defects that are marked in red are detected in stage 1, green in stage 2, and then there's a third one here, magenta. So this defect was detected in stage 3 block detection. The performance of the system is measured using 4 criteria. They are the speed, accuracy, misdetection rate, as well as false alarm rate, calculated using the formula listed here. In terms of speed, the system has an average of 0.7 seconds to process the image. Model 8258 and 8951 require longer processing time than the rest. And this is because there are 3 outliers that took an extremely long time of 19 seconds in the convex hull algorithm. So if we were to exclude these 3 outliers, the processing time is reduced to about 0.5 seconds per image. In terms of accuracy, the overall accuracy of the system is 89.58%, with a misdetection rate of 12.4% and a false alarm rate of 9.6%. So comparing to the previous work, even though the improvement in the overall accuracy is small, the reduction in the misdetection is significant. So in a more detailed analysis, it was found that misdetections are mainly attributed to some faint and small defects, as shown here, as well as defects that are located near the ROI boundary, as shown in this example, where the defect is actually merged into the background. As for false alarms are mainly due to the ROI boundary distortion, where noise are present due to texture surface and the lighting angle, and this was falsely detected as a defect. The second contributor to false alarm is the feature distortion. So in this example here, this wiper arm feature was again wrongly detected as a defect. So in conclusion, the proposed system actually improved the accuracy slightly to 89.58%, with the significant reduction of misdetection from 52 to 12.4%, and the false alarm rate of 9.6. And this is achieved by improving the performance on all stages of image processing with the technique listed here. Future improvement can be done by exploring the use of machine learning technique based on the image sequence acquired, and also learn the wiper arm features to prevent them from being detected as defect in order to enhance the defect detection stage. That's all for my presentation. Thank you very much for listening.
Thank you very much for your presentation. Is there any question, comments, or remark? There's no question. Thanks again for your presentation.
Thank you.
Name of the next speaker is Mustafa Salim. The title of his talk is A Model for Semantic Relation Extraction from Unstructured Text.
Assalamu alaikum.
Alaikum salam.
Sure.
Mr. Salim?
No. Assalamu alaikum. Is the screen appear in your? Is the screen shared with you?
Yes, we can see your screen.
No. Good evening. My name is Dr. Ban Mustafa. I will present to you the paper named with duty to KB, a model for semantic relation extraction from unstructured text. I'm from Muslim University. First of all, the outline of the research will be the motivation and objective, introduction to the topic, and the model architecture, experiment, model evaluation, and conclusion. First, the motivation of our work has come because of the huge data that's available in random shape in the web. There is a need to extract this information automatically and convert it to a structured data that can be processed and created by machine. Most significant form of extracted information comes in the meaningful relations in Rdf triple format. This can be used to update the ontology and building a knowledge graph. DBpedia can be considered as one of the first projects that aiming to extract the structured content from information created in Wikipedia project, and this structured information is made available to the World Wide Web as Rdf. DBpedia can be considered as the heart of the linked data that comes in www. Objective of our work is to build an intelligent prototype model to convert the unstructured text data to Rdf triple, mapping the Rdf triple to specific domain ontology using the WordNet lexical database. The domain ontology can represent a knowledge graph that can be queried and searched for specific information. First of all, we have some definitions as a previous knowledge. Information extraction field can be defined as the process of parsing through unstructured data, extracting essential information into an editable unstructured data format. In general, it consists of main steps, including the text preprocessing, concept detection and classification. Identifying linkage between the retrieved concept is the task of connecting the concept and at last unifying. Ontology can be defined as a formal specification of a shared conceptualization. It is, can be represented by the collection of URI entities that has a meaning. Ontology represents vocabularies and knowledge base for a specific domain. Ontology built on the basis of RDF, and it made up of classes, properties, instances, properties, values, and instructions. The term ontology-based information extraction can be also defined as a system that processes the unstructured or semi-structured text and extract the new information according to ontology. The main architecture for any that can be abbreviated for any OBI system can be abbreviated in this diagram. First of all, we have the text input that enter to a preprocessor stage, and then another stage for information extraction model depend on ontology and semantic lexicon to provide us with a knowledge base or as a database that can be queried and used by a user. Ontology can be built by a human or can be generated by an ontology generator. The unstructured to knowledge base, this is the abbreviation of the model. The model architecture can also be abbreviated by this diagram. We have the document, which is a natural text document. This is an input to the text processing stage. The output of this stage is a set of sentences. This is the input for another stage, which is named by Rdf extraction. Rdf extractions from the output of this stage is a set of Rdf. Another stage is Rdf refinement that enhanced the first Rdf extracted to another set of Rdf that is based on our ontology. And then we have the ontology mapping, the last process, to get an ontology that represents a knowledge base. The first stage, text processing, can be abbreviated in this diagram for we have some steps: the covariance resolution to get a resolved document, the tokenization to get a set of sentences, and then punctuation mark removing to get a set of a clean sentence. The next stage, Rdf extraction. We have a set of sentences. This is an input for the semantic rule labeling. In this model, we used Allen NLP semantic rule labeling to convert these sentences to semantic framing structure. Also, we used named entity recognitions and part of speech tagging as a tool for helping the work in this stage. After these sentences come as an input to semantic rule labeling, we get a predicate argument, a set of predicate argument structures organized and arranged to get a set of a triple shape as a subject, verb, object. Then we have Rdf creation. This is stage used works with the help of part of speech tagging and named entity recognitions. Rdf is being mapped, also is being an output as a set of Rdf. Next stage, Rdf refinement and ontology mapping. The set of these Rdf enter to the steps of similarity checking. We used WordNet lexical database and the specific domain ontology built by expert to get also we have a threshold to determine how these concepts semantic related to the domain specific concept, and get an Rdf based ontology to be added to ontology and get the knowledge ontology. For the work of or to see how the work of this prototype model works, we have an experiment. Mohammed speaks English and French languages, while John speaks English only. Both Mo and Johnny reside in London City. Mo help with this abbreviation for Mohammed, Johnny for John. First of all, we have this domain-specific ontology for country. The ontology consists of a specific concept like language, religion, person, city, country. Capital is a subclass of from city. ASEAN country, American country, European country, African country is a subclasses of country. We have a relations between these classes called it property. Like we have a country has religion and the person speak language. Also, we have contain capital. This relations is the inverse relation. Country contains city, city located in country. This ontology is built by Protege tool. SRL example, as we said before, we use Allen NLP SRL trained model. SRL help take any sentences, produce a set of predicate argument structure. Predicate argument structures represented as a verb. This is the main part. Any verb must have A0 as a subject and A1 as an object. This sentence has two verbs, speaks and speaks. We have two predicate argument structure, one for the first speak and the other for the second speak. Any sentence can produce more than one predicate argument structure. For the above example, we have three predicate argument structures produced. Muhammad speak English and French language. John speak English only. Both Muhammad and John, we get it after making a coherence resolution, which return Mu as Muhammad and Johnny as John, reside in London City. The initial triple shape with NER and post tagging will be Muhammad speak English, Muhammad speak French, and here we have A0, and the predicate English as the first object, subject predicate French as a second object, two RDF produced from this. Muhammad speak language, this is the third one. John speaks English for this one, and Muhammad reside in London. John reside London. Muhammad reside city. John reside the city. This is the output of the first stage of RDF extraction. RDF refinement and ontology mapping. The first step of this stage is to extract all the is-a relation. We divided the relations into two types. One is a, and the other is non-is-a relation. Is-a relations corresponding to the instance class relations. All proper noun entities will be mapped as new instances to predefined ontology classes. Muhammad and John can be considered or can be added as a new instances for a class person. London is an instance of a class city. English and French are two new instances for a class language. We get these instances by using the WordNet lexical database to get the similarities matching between these instances and the classes in domain ontology. The second stage is to extract the non-is-a relations. The two instances are related by predicate. Predicate will be mapped to ontology properties. Here predicate or the verb would be mapped to ontologies properties, also using the word network. The predicate does not have a semantic similarity. If a predicate does not have any semantic similarity or did not get the threshold, we put it first, then the RDF triple will be discarded. For the above example, following RDF triple will be added as a new assertion to ontology. Muhammad speak English, Muhammad speak French, John speak French, Muhammad live London, and Job live London. The two predicates reside and speak map to the most similar ontology properties live and speak respectively. This is the new ontologies produced after adding. This diagram represents the ontologies after adding, not just this example, we used a larger text. We see here the instances that we added and the relations between these instances and classes in ontology. The evaluation of the model, we use the precision call and accuracy test. The first stage of RDF, of the initial RDF extractions, this is the value of precision and recall and the F1. The second one will represent the evaluation for is-a and non-is-a relation in general. We get a better accuracy, 75, 70, and 72. As a conclusion for this work in this paper, the UT2KB model proposed for extracting structured information from unstructured text with the help of specific domain ontology. Model will use the NLP task from an NLP platform. The extracted triple refined to be more suitable to ontology concept and the properties using the similarity techniques of work. Model results depend on how to find semantic similarities between the extracted RDF and the domain ontology concept and the properties. Result we showed the WordNet. The result we get it, we showed that WordNet is not a great tool. for giving similarities. Because of the lack of information offers in some subjects offer, also it is weak work in with the similarity, with verb similarities, getting verb similarities. Other ways can be implemented for semantic similarities testing, including global vector representation, with the help of cosine similarities and equidistance distance. The GLOVES is an unsupervised vector model introduced by Stanford University, used to represent each word in a corpus with a single unique vector and a low dimension. It is built on a training of a covariance matrix representation technique. Appear how frequently word is used together with other word in a corpus. We used the two ways and to make a comparison, so shown in this example for some two similar concepts. Muhammad person. Muhammad, this is an entity, and the class is person. We showed the value in coordinate iterativity. In GLOVES, by cosine similarity, we showed 64.837, which is much better than WordNet. Mike and person also showed this value. Ahmed person in WordNet it is 0, and the GLOVES cosine similarities we have 61.7. English language, Arabic language also showed that the GLOVES embedding works much better than WordNet. In future work, we are determined to find an efficient way to improve the performance of the model in application of ontology mapping. Thank you for listening.
Is there any question, comments, or remark? No question. Thank you very much for your presentation. The name of the next speaker is Miroslav Marina. The title of the talk is Social Data Analytics for Enhancing the Collaborative Economy. Now we can see your screen. You can start.
Yeah, thank you very much, Mr. Chairman. Good afternoon, everyone, or in Turkey, it's almost good evening. My name is Miroslav Marina. I come from the St. Paul the Apostle University of Information Science and Technology in Ohrid, Macedonia. And I will present a work on the social data analytics for enhancing the collaborative economy. First of all, I would like to give credit to my co-authors, Professor Atanas Christov, Professor Alexander Pinche, and our two collaborators, Ms. Natasha Dimoska and Mr. Mirsad Sefidanovsky. This is one picture of our beautiful UNESCO town or city of Ohrid, which is located in the south. Motivation for our research. We were interested to visualize plenty of the business insight that we use applications. So how do we do it? Maybe through some social data analytics. And then what we wanted to monitor one thing that is very straightforward, that is very classical, is the return on investment. And then the other thing that is a little bit more modern is the return on collaboration. Actually, I will give an emphasis in this talk on this return on collaboration, and we will see what does that mean. And then combining these two, maybe we will get some conclusion on how to enhance the collaborative economy of the future. This task, this exercise was part of our Horizon 2020 project called RTConf, with a full name Smart Social Media Ecosystem in a Blockchain Federated Environment, which has for goal to create a decentralized and federated social media ecosystem. And then this ecosystem will be supported as an enabler by the disruptive blockchain technologies. And then we want to the main task of the project is to create a portable intra or cross-platform social media data. And then within this project, we have 4 tools that we develop. I'm not going to go into details through all the tools, but we are focused in the last 2 called tools for analytics and cognition. That means the tool that is collecting the data from the previous tools and then creating a value out of it, either in terms of the metric for return on collaboration or return on investment. Within this project, we have 4 use cases. One of them is peer-to-peer car sharing. So everyone knows the Uber or other type of car, let's say car on demand, car sharing or carpooling. But here we don't have a central authority like the company called Uber. It's a peer-to-peer. Who is the guarantee of the whole platform is the blockchain. Then the second use case is the smart renewable energy trading. So imagine your household produces a green energy with whatever renewable technology. It can be, for example, solar panels, and then you want to sell the energy to your next door neighbor. You don't need to go through the distribution companies, which will take commission from both of you for nothing, but you can sell the energy next door. How to do it? With the blockchain. The third use case is the video content and opinion sharing. The blockchain is used to embed the video and all this media content together with the intellectual property and preserved, recorded on the blockchain. And the last one is the crowd journalism. It's anyone can be a journalist, can report with their device, whatever happens, but we want to create a trustworthy system that will not use fake news. So again, here the distributed ledger called blockchain is the guarantee. These are the partners: University of Klagenfurt, University of Amsterdam, University of Edinburgh, our university in Macedonia, and then Beat Yoga in Norway, Agelia Center in Spain, Emoji Technologies in Portugal, and Vilog in the United. What is blockchain? Probably many of you heard it. Many of you, when they hear blockchain, they think Bitcoin or Ether or any type of cryptocurrency, and then various people get scared. They say, oh, this is dirty, dark money. Many people see an opportunity. Oh, this is an opportunity to earn money. We as academics and engineers, we see an opportunity, much bigger opportunity of within the blockchain as a concept. Not only to earn money short term as a trader, but also to use the properties of the blockchain for creating different models and different businesses. So it's basically the blockchain through its structure provides trust for various businesses that are impossible to do with a paper, classical paper interactions. So now this is the flow model of our architecture. We have data collection from several of the other work packages of the other segments of the project, like which we call with these names of smart tick, and then we have we process this data, and then we some kind of visualization such that we can easily follow what's happening in these 4 scenarios, 4 use cases. In this talk, I will just address 2 of them, the energy case and the car sharing case. So our tools for analytics and cognition, it's software, analytics software to aggregate and then ensure augmented cognition and interactive visualization. And then we create a dashboard that we can monitor what's going on. In the case of car sharing, a very nice visual tool to how to choose your share a car when you want to hire a taxi, or when you want to carpool within the city, for example, or the energy, in the energy case, to see what is the energy that you personally produce and what amount of it you can offer on the market. And then this is still a proof of concept because it's within the project. And then we want to implement this easily visible return on investment and return on collaboration. Plenty of you use various applications, I don't know, from booking plane tickets to hotels, and then there is a lot of metrics there, a lot of ratings, and then this so-called gamification can provide a better user experience, and then you can make a better choice of the service or the product you want to use. And then this we want to create this cognitive analytics to offer various business models for so-called collaborative economy of the future. And then how to do that? If it's a peer-to-peer system, maybe the more users are engaged, the better the experience. And then how to rate the users. So imagine in the car sharing, you have drivers and you have the passengers, and you can be either of them. Sometimes you can provide your car for car sharing to reimburse some part of the trip. There are plenty of models like this. One of the famous European companies, BlaBlaCar in France, is one of them, where you can, if you travel on intercity travel, you can pick some passengers on the road, and then you can share the cost of the trip. Here in this peer-to-peer model, we really focus on intra-city, so within the city borders, displacement. So it's like a taxi, but something that goes every day, and then you can do it using blockchain. You can pay with cryptocurrency, and then everything will be comfortable because you have trust in the whole system. And then we wanted to define this return on collaboration. So we want to see how this engagement rate of the user can be reflected in a metric called return on collaboration. Classical return on investment is really measuring on how you measure the profit you make minus the investment you did, and then you want to have it in percentage. So for example, you have like 20% return from your investment, and then you can decide about your strategy, where to invest, and then you get some insights on other business opportunities. Here we did some metrics on the data that we simulated for the car sharing, because most of this data that is real, it's under the protection of the GDPR, the General Data Protection Regulation, and for that reason we had to simulate some of the results, and then we were getting some numbers for within a certain period of time to see how much out of the trip price, how much is the reward, and how much is the return on investment. So it's some kind of visualization on the car sharing. And then this is a little bit more smaller, but still we can get an impression that we got some return on investment in the case of the energy marketplace. Here we use the real data from one Australian region around Brisbane, the Gold Coast around Brisbane. So we're using the real data, and we were measuring on very, very precise dates by the end of 2012, beginning of 2013, how was the return on investment in the energy marketplace related to the price of the kilowatt hour at that time. And now we really introduce a new innovative value that quantifies this engagement rate, return on collaboration. It gives an estimate on how we utilize and monetize the collaborative channel, how the stakeholders are involved, and then how the user's activity, the user's collaboration will bring revenue to the stakeholders. And then we try to model it through measure this revenue through user engagement activities. And then we did through the engagement rate measurement, and then try to get some insight. And this is how we defined it. Engagement rate in percentage is earning per user, and then divided by the revenue per application service, and then we want to do it in percentage. These are the results we got from the simulated data in the car sharing use case. What is the average engagement rate? And then for the energy marketplace, what is the engagement rate according to the equation that. So to conclude, we wanted to define a new return on collaboration metric on the data we have, and for the end of the project, we will implement all 4 use cases and see how it works with the real data. Then we compare to the return on investment monitoring, and then we feel that this return on collaboration is an important aspect of the future economy, of the so-called sharing economy, because usually we speak about monetary economy in which everything is measured by money, but in this sharing economy, there is something a little bit more than money. It's this collaboration that is very precious. And like in the past, classically, maybe you could share the car with your neighbors or relatives or colleagues, but now you are getting a platform through the disruptive blockchain technologies that will provide this trust that you had in the past, intrinsically knowing directly the community, the people that are close to you. And these are our contacts. You can scan also the QR code of the Articom or just go to articom.eu and see the details about the project if you're interested deeper. And then Chuck Teşekkür. Thank you very much.
Thank you very much for your presentation. Is there any question, comment, or remark? No question. Thanks again for your presentation.
Thank you, Mr. Chairman.
The name of the next speaker is Oluwajuan Olawale. The title of the talk is Data Mining Techniques for the Classification of Medical Cases, a Survey. Okay. We can see your screen. You can start.
Okay, hello everyone. My name is Oluwaseun Priscilla Olawale, and I'm from the Department of Computer Information Systems, Nearest University in Northern Cyprus. So today I'll be presenting on data mining techniques for the classification of medical cases, and this is actually a survey paper. The other authors are Fezile Ozdami and Camille Demilila. So here's our agenda. I'll take you briefly through the abstract introduction, the methodology that we employed for the survey paper, the results, we obtained, a little bit about the discussion, and then finally we conclude. One of the rich data fields is the biomedical realm. There are detailed biomedical records ranging from the clinical conditions to different types of biomedical data and imaging equipment outputs. However, here the problem is the manual extraction and transformation of biomedical patterns into mechanically comprehensible information. And this can sometimes pose to be a difficult challenge because the biomedical field includes broad, dynamic, and complex knowledge. But the main aim of this paper is to analyze some of the available data mining patterns for the classification of medical cases with the systematic literature review. The paper studies and techniques that are commonly used for prognosis, classification, prediction, and treatment related to recurrent and significant diseases like cancer, hepatitis, and cardiac diseases. So the keywords for the paper are data mining, machine learning, healthcare, biomedical data, and medical. So yes, the biomedical field actually includes broad, dynamic, and complex knowledge because it also includes different subdomains that deals with DNA, cells and tissue, the organs, brain, body, and of course, yes, the imaging equipment outputs that produces scans of MRI scans and the X-rays. But so there are also data mining tools for the extraction of this data. And most times we have to apply artificial intelligence, machine learning, and of course use databases while doing the process of the data mining extraction. The increase in medical conditions has made use of data mining techniques common at this stage, in which the most important causes of mortality are infections. Take for example, in the previous year we had the COVID that took lives of many people. Studying the patterns, the symptoms of COVID and everything is very necessary in order to be able to preserve patients' lives. So as a result, many researchers are interested in gaining valuable information from available evidence to help doctors, which is the main thing, to help doctors make quicker decisions and reduce the harmful effects of certain diseases. Data mining techniques can analyze and classify massive amounts of data, grouping variables with related behaviors and potential forecasting incidents, among other benefits for tracking and controlling health facilities that are constantly trying to protect patients' privacy. And in this study, we raised 3 research questions to be able to find data mining techniques. The first one is what data mining techniques are used in the medical field? The second one is what medical cases are these data mining techniques used to classify? And finally, what rate of success have these data mining techniques achieved? So for the methodology, we actually adopted the PRISMA model, the preferred reporting items for systematic reviews and meta-analysis. And we make use of 3 databases, EBSCO, the IEEE Explorer, and Scopus. Part of the selection criteria was to use study papers between 2015 and 2021 and focus on papers that were written in English. So in finding all of this, we for EBSCO we found 4 papers, for IEEE Explorer we found 64 papers, and for Scopus we found 151 papers, making 180 articles in total. So in screening, we were able to remove 31 duplicates, and further screening, removing papers that were not written in English or totally out of context, not related to what we said. We were able to remove 117 papers, leaving us with a total of 56 papers. And then we further screened because we couldn't have access to some papers. Some of them required payment, and some other papers that were not computer science related, since the field we're working from is computer science. And then we're finally left with a total of 17 papers. So these 17 papers are papers that we actually used to organize our results. And from our results, in answering the first question, what data mining techniques are used for classification of medical cases, we found some of these, the SVM support vector machines, made bias, radar basis function, network decision trees, and the rest of them. And some of the medical cases we found from these papers include cardiovascular diseases, measles, diabetes, insulin treatment, thyroid dysfunction, dengue fever, tobacco use, PCOS, breast cancer, skin cancer, and human emotion. And this time we found a paper that was discussing mental health of papers. And from the correlation of the results, we found out that support vector machines and CART, which is actually classification and regression trees, did produce the best results. This is a sample table that references the main table from the paper. For example, the first one, long short-term memory, which was the only technique the authors referenced in that paper. They used it to study the heart disease, and they found that this technique, the long short-term memory, actually produces a good result for categorizing, predicting heart diseases. Then there are some other ones. For example, another example is the dengue fever, the random forest and decision tree. And it was found by these authors that the strategies are efficient for measuring existing illness situations to reduce death rates and future measurements that must be taken, which is actually one of the aims of this paper, to provide information for doctors to be able to save human lives. In the discussion section, found out that many data mining approaches are accessible to work on many parts of research, particularly in the biomedical sector. The data mining methods utilized are determined by complexity of the algorithm used. The most often used data mining techniques in biomedical sector are artificial neural networks, ANN, decision trees, and net bias. The support vector machines, principal components analysis, the k-nearest neighbors, and rainforest are other methods that can also be employed. And for medical cases, when data mining techniques are applied in studying machine learning techniques that are commonly used for prediction of surgical instability, for example, prognosis and treatment of recurrent and significant diseases like cancer, we find out that there is an efficient way to be able to detect, to identify and detect the disease online, to be able to identify and detect the disease on time, thereby providing solutions to be able to save the patient's life. And for our study, actually, the common data mining classification techniques that were found are support vector machines and the classification and regression trees. And in conclusion, data mining can enhance healthcare choices, enabling medical doctors to classify and predict diseases, thereby increasing patient survival time. The researchers of this study hope that this research provides information on data mining classification algorithms that may be utilized to study medical cases that are not even mentioned in this study. So this is the end of my presentation. Thank you. Once again, my name is Oluwaseun Olawale, and I'm a PhD student in the Department of Computer Information Systems at NERIT University in Northern Cyprus. And this is my email in case you want to reach me to request information. Thank you so much.
Thank you very much for your presentation. Is there any question, comments, or remark? There's no question. Thanks again for your nice presentation.
Thank you.
The name of the next speaker is Rana El Masri. The title of the talk is Environment Recommendation for Product and Community Prediction. Mrs. Rana is absent or present? Okay. She's absent. The next speaker is Martin Jonov. The title of the talk, Solving IoT security and scalability challenged with blockchain.
Hello, do you hear me?
Yes.
Okay, great. Hi, my name is Martin Jonov, and I'm coming from the St. Cyril and St. Methodius University of Veliko Trnovo in Bulgaria. So together with Professor Miroslav Galabov and Satanka Georgieva Trifonova, we did actually one paper regarding the solving IoT security and scalability challenges with blockchain. So actually there are three parts in this paper. So the introduction, the components, and analyzing the results. What is actually Internet of Things, what is blockchain, and what are security and scalability in matter of IoT. So Internet of Things, it was very huge buzzword in the past, but now it becomes part of our everyday life. So there were around 20 billion of devices active out there in 2020. And the idea of Internet of Things is to have a huge network of all devices that have access to the internet. Blockchain, usually, as the previous colleague mentioned, is often misused with the word cryptocurrency. So to be clear, the blockchain is only a specific type of a database, which actually I will explain more how it works. And the security in IoT and scalability in IoT are actually connected to 4 different layers in the IoT network. So having in mind that one IoT network is connected from devices and actuators, middlewares that are gathering that information, then cloud network itself, and at the end, the application. So we have to be sure that we are covering all that kind of security and all that kind of scalability. So I will talk about all of these parts in details afterwards. So what is the goal of this presentation and of this work is to present that actually we can use one specific private blockchain network to resolve the problems with security and scalabilities in IoT networks. So what are actually the components of this work? It's a blockchain network, a Hyperledger fabric architecture, and smart contracts together with a chain code. I will explain which one of these is actually important for the implementation of security and scalability, but all of them play a huge role in all that environment. So this is one presentation of how blockchain network looks like in the terms of Hyperledger fabric. So we can see that there is the network itself, there is a channel, there are a few different organizations, and there are multiple peers and applications. So if we take one example, let's say that we want to do some kind of a hospital on the Hyperledger fabric. The hospital could be one organization 1, then organization 2 could be some other institution that needs to share the data with the hospital, and then organization 3 can be some kind of benefits broker that also need to have access to the data. So the channel will actually be chain code of all the data that exists in that blockchain network. So probably the patients and all the treatments and similar to that. So I'm just giving one parallel of how to understand this blockchain network. Then the peers could be actually doctors that are actually, in this case, kind of computers that are running and are doing something regarding to the data, while the application is actually the application itself that it's consumed by the patients that can discuss and talk to the doctors and get treatments and so on and so on. So Hyperledger fabric architecture, it contains a few different important parts. So I will start first with the fabric CA or certificate authority. So that's one component that it's important because it actually issues all the certificates, and it serves us kind of to identify the people or the, let's say, the peers and all the components in the networks for some kind of an authentication. Then we have peers themselves, which, as I mentioned, we can think of them like a kind of computers that are hosting the ledgers and smart contracts, or they are computers which run and help run and maintain the network and also verify and endorse transactions. The ledger itself is actually, it stores all the information about the business objects, the current value, and also the attributes of all the objects that are stored in the blockchain, I would say, database. And it also contains all the history of transactions that resulted in these current values. So we can think of that it contains two parts like blocks and world state, where the world state in a matter of, let's say, banking application will be the current balance, while blocks is actually the hierarchy of the transactions that happened to get to that current balance. There could be a situation where some of the organizations from the previous screen would want to have specific data that they don't want to be shared with other organizations. So that part is covered with the private data in the Hyperledger Fabric actually network. So compared to how this works in IoT, we will see on the slide afterwards. So this is just a basic introduction of the Hyperledger Fabric architecture. And what is the chain code? The chain code is actually the program that could be written in Go or Node.js or Java in Hyperledger Fabric. And it actually implements the interface that initializes and manages ledger states through transactions submitted by all the applications and peers in the network. So the ordering service, it's also an important part in the Hyperledger framework because Hyperledger Fabric works differently than the other algorithms out there. And the idea is that it features a node, which is called an orderer, which is also known as an ordering node that does the transaction ordering, which along with other orderer nodes forms an ordering service. So the idea is that this Hyperledger Fabric algorithm uses deterministic consensus to verify the transactions. So I will just go back to explain how the blockchain database works. So actually, whenever new create operation from the CRUD concept that we know comes, there is a new block that is getting filled and it's attached to the last transaction. And we will see later in the results why this will give us ability to have kind of security in IoT. Okay, so in terms of IoT network, how this works in conjunction with the smart contract. So we have a kind of an IoT network where we have actuators and devices that are collecting sensors that are collecting some data and actuators that are actually doing something based on some event. So let's imagine that our sensor is some kind of sensor that measures the current temperature in the room, and the actuator will be kind of air conditioner that could do cold or hot air. So we have a smart contract developed for this work, and the smart contract has actually 8 different parts. So what is actually a smart contract? We can think of it of kind of a contract between all the people that are going to be part of that. That's not all the people, but all the parts in the IoT network that will have to do something with the information. So in this situation, that's a middleware that gathers information and communicates with the cloud service itself, all the sensors and all the actuators. So there are 8 parts of the contract. So the first contract is actually retrieving the information when the information gets written to the blockchain. Then we have the sensor, which sends the information to the middleware. So passing the information to the middleware to know which middleware is receiving information, so who is responsible for that sensor. Then sending the information to the cloud environment. It's a separate part of the contract where we also need to know which service actually got the information, because if we have like load balancing and scale environment in our cloud provider, then we could have multiple instances. So we really want to know who is going to be responsible for that action. Then when the service receives the information, it adds the received part to the information that it's received with the ID of the service itself. Then it invokes some kind of an action based on the let's say, temperature that got here. So let's say that the moment is 40 degrees in the room. So we need to turn the air conditioner on. We deliver as part of the delivered part from the smart contract, we deliver that information to the middleware, which afterwards delivers that to the actuator and back to the device itself, which could be, as I mentioned, air conditioner. So that's how one kind of an IoT network with conjunction of the smart contracts and blockchain will work, and how the data will get passed from the devices, which could be sensors, all up to the actuators that will do something based on some kind of an event. So this is how smart contract looks like. As I mentioned, it can be written in Go, in Node.js, or in Java in the matter of Hyperledger Fabric. So it is basically a class that extends a contract which comes from a package called Fabric Contract API. As we can see, there is an instantiate method and there is a create information method. So if we go back, we can see that actually the first part of the smart contract is create the information. So what it does, it verifies that the sensor that actually we are going to use is in the existing network. Then it pushes the information which contains like the value that we got from the sensor itself, what action we'll get, and what is the current status, which is the sensor ID, and so on and so on. And then at the end, it puts the state into the blockchain. So afterwards, we can see that after the information got written to the blockchain, it has this kind of a transaction block structure. One transaction block structure has a few important things that are actually going to provide the security that we want to enforce in IoT, and that's this specific part, data hash. So the idea is that the data hash contains a hashed string from the previous transaction block. So here we have number 27, and the data hash contains hash string from the transaction with number 26. So what actually security we enforce with this is that no one can tamper with our data, because if someone's changed the object itself, then this data hash will be invalid because it will not be the same as the previous block, and we could actually then determine that something is going wrong with the database. So we can take some cautions for remediating that issue. Following the other parts of this transaction block, we have the transactions part, which could be only one or multiply transactions in the same block. So this one contains only one transaction, where we can see that we have writes and reads. So the idea is that based on what I show in the previous smart contract part, we are writing the information, and we are also writing the data that the sensor came up with. And this is just some kind of a metadata that is part of that transaction block. So then we used also Solitaire to actually do a benchmark based on the network itself. So on the Hyperledger Fabric network that we developed with the smart contract that I just showed. So running on a machine with a Docker Linux container with 1 CPU and 4 GB of RAM. We initiated like 2000 transactions, where the send rate was 50 transactions per second. And we can see that the average latency got to 0.16 seconds. The true output is 50 transactions per second, which is same as the send rate, which actually tells us that only with 1 CPU and 4 GB of RAM, we can achieve this kind of small latency. And we can imagine going back to this Hyperledger Fabric architecture, where each peer will be one of the parts in the IoT network, where it could actually do this kind of transactions per second, that we can achieve very high scalability, because we will not rely anymore on having to go through one centralized network, where the centralized database will be actually the the cloud provider itself, but it will be the blockchain where each of these parts can talk in between and can interchange data in between, while keeping the data secure by preventing tampering it and unallowed access, and also ensuring scalability, which scalability in the matter of IoT will be that the function and the sensors and all the parts of the IoT network are going to continue serving the purpose, even if there is higher workload. So yeah, in short words, the Scaliper is actually a Hyperledger benchmarking tool, which can be used for testing the network latency and the network scalability. So yeah, that's all.
Is there any question, comment, or remark? No question. Thank you very much for your presentation. The last speaker of this session is Radostina Angelova. The title of the talk is Method for Measurement for the Metabolic Carbon Dioxide Concentration Through a Small Climate Chamber. Radostina. She's present or absent? She's probably absent. Okay, thank you very much for your participation to attend this session of international conference. Wishing to meet in other sessions and other international conferences.
Thank you very much.